Find the inverse of each relation. Part A. To find the inverse of this relation, switch the coordinates of each ordered pair. So -2, 6 becomes 6, -2, 1, 5 becomes 5, 1, 4, 4 becomes 4, 4, 7, 3 becomes 3, 7, and 10, 2 becomes 2, 10. So the inverse of the given relation is 6, -2, 5, 1, 4, 4, 3, 7, and 2, 10. Part B. To find the inverse of this relation, switch the inputs and outputs. So the inputs of the inverse of the given relation are 2, 4, 6, 8, 10, and 12, and the outputs of the inverse of the given relation are 0, 2, 4, 4, 2, and 0. Let f of x equal 3x minus 5. Solve y equals f of x for x, then find the input when the output is 4. Begin by setting y equal to f of x, giving you y equals 3x minus 5. Now you want to solve for x. To do this, first add 5 to each side, giving you y plus 5 equals 3x. Then divide each side by 3, leaving you with the quantity y plus 5 divided by 3 equals x. Now you want to find the input when y equals 4. So substitute 4 for y and simplify. 4 plus 5 is 9, and 9 divided by 3 is 3. So the input is 3 when the output is 4. Find the inverse of f of x equals 3x plus 4. Begin by writing the function, then set y equal to f of x. Now switch x and y in the equation and solve for y. To solve for y, first subtract 4 from each side, giving you x minus 4 equals 3y. Then divide each side by 3, leaving you with the quantity x minus 4 divided by 3 equals y. So the inverse of f is g of x equals the quantity x minus 4 divided by 3. Find the inverse of f of x equals 1/2 x squared. X is greater than or equal to 0. Then graph the function and its inverse. Begin by writing the function, then set y equal to f of x. Then switch x and y in the equation and solve for y. To solve for y, first multiply each side by 2, giving you 2x equals y squared. Then take the square root of each side, giving you the positive or negative square root of the quantity 2x equals y. Because the domain of f is restricted to non-negative values of x, the range of the inverse must also be restricted to non-negative values. So the inverse of f is g of x equals the square root of the quantity 2x. Now you want to graph the function and its inverse. So graph f of x equals 1/2 x squared, and g of x equals the square root of the quantity 2x. You can see that the graph of g appears to be a reflection of the graph of f in the line y equals x. Consider the function f of x equals the square root of the quantity x minus 3. Determine whether the inverse of f is a function, then find the inverse value. Begin by graphing the function f. The horizontal line test says the inverse of a function f is also a function if and only if no horizontal line intersects the graph of f more than once. You can see that no horizontal line intersects the graph more than once, so the inverse of f is a function. Now you want to find the inverse. Begin by setting y equal to f of x, giving you y equals the square root of the quantity x minus 3. Then switch x and y in the equation and solve for y. To solve for y, you first want to square each side, giving you x squared equals y minus 3. Then add 3 to each side, leaving you with x squared plus 3 equals y. Because the range of f is y is greater than or equal to 0, the domain of the inverse must be restricted to x is greater than or equal to 0. So the inverse of f is g of x equals x squared plus 3, where x is greater than or equal to 0.